Hi, this is Arnav, and in this video, we are going to be covering a low-level design problem, which is actually a very popular problem to solve, both in terms of interviews and also just as a LLD practice case study, very common, which is designing a tic-tac-toe as a game. Something probably as simple as this might not come in a real interview, might be a little more complex, what actual interview low level design problem statements might be, but this is a good place to start off from, to get an understanding of how game kind of things are designed. And there are a lot of game system design questions that come in interviews, for example snake and ladder or a wordle game, things like that. So quickly, let's start by understanding the problem statement first, and then we will go on to actually write the code for this. So the problem statement is that we have to design a command line based 3x3 grid tic-tac-toe game that can be played by 2 players. So it depends on how the problem statement is given to you. In this particular problem statement that I am showing here, the problem statement itself specifies that the board, the numbers of the boxes should be A1, A2, A3, B1, B2, B3, and C1, C2, C3. Sometimes this might not be specified, and it's up to you to decide whether you want to number the boxes as 1, 2, 3, 4, 5, 6, 7, 8, 9, or by 1, 1, 1, 2, 1, 3, like that. Is a 2x2 matrix kind of a setup. But in this case, we have been said that we should number the board like this. The game should have 2 players. Every player by default has the character X and O, which is crosses and O's for tic-tac-toe, but player should be able to pick their own character if they want to as well. So if somebody wants to go with, say, an emoji instead of X, right, they should be able to do that. And both players must not have the same character. That's something that you have to add into the logic of the game, and every player has a name as well. Then there's the game. So the logic of the game is that the game starts with player one inserting the character on one of the boxes, and players get alternative turns. Some additional complexity that is possible here is, maybe, if you're facing this in an interview, somebody can say that, okay, add a toss facility in the beginning which randomly decides whether 1 or 2 player will get it. In this case, player one will always start. Players will get alternative turns. On every turn, you ask on the command line which input box that the player wants to insert their character into. And after every turn, we show the state of the game, basically show the state of the board at this stage. And along with that, we are supposed to do one of these things. So we need to do, like, if player specifies the wrong box, then the player gets to try again. If the player selects the correct box, in that case, this move itself might end up winning the game. So either do that, or the player does not win the game yet, the game will continue. Or maybe it is that this is the ninth move. So if it is the ninth move, then the game ends and it's a draw. So handle all these cases. Winning condition, as happens in a tic-tac-toe, is that the same symbol in one row, same symbol in a column, or same symbol in a diagonal. Okay. The data format for the game is also given in this case. Sometimes it's given, sometimes it's not. Here it's saying that to initialize the game, we have to do something like this: enter player one name and then enter player two character. By default is X. Enter player two name, enter player two character. By default is 0. I think this should be player one here. A little bit of a mistake there in the problem statement. Then the gameplay is, it will always show the board first. This is the state of the board. Then enter player one's move. Player one adds move to A1, so player one's character gets added to here. Player two enter box. Player two goes for A2, and so on. That's how it will go. Some expectations are given to us. So make sure you have a working and demonstrable code. Make sure the code is functionally correct. Code should be modular readable. Separation of concern should be addressed. General stuff in mostly all things that are given. Do not write everything in a single file. Separate out your code base. Code should easily accommodate new requirements with minimal changes. Write unit tests wherever applicable. That's an important thing. We will have to write unit tests, and optionally some requirements are that if we have time left, keep the code extensible to change the size of the grid. Keep the code extensible to allow different types of pieces. Keep the code extensible to allow more than 2 players or pieces or types. Okay. So apparently these things, if possible, we have to do that as well. So let's first try and see how to code the minimum requirements, and then we will see how we can maybe add the optional requirements to the game as well. Okay. Okay, so before we start coding the solution for our tic-tac-toe problem, just a quick note on the setup. So I'm doing it using TypeScript for this video. So just a simple idea about I have the TypeScript compiler and just installed for running the tests, TS node, so that I can execute my TypeScript files. And we've got a src folder where we have the main file where we will write our code, the test folder where we will write our tests, the package.json file which has the start script which runs ts node. That's all. Most of these setup is usually not going to be important in a interview kind of a setup, because generally you have a hacker rank or some online id inside which you will write the code where the setup is sort of done for whatever language you're going to be picking. But this is just to set up a base line from where we will start with. Okay. Usually you are not allowed to install any libraries as such. So the only thing libraries that I actually have installed here is just for testing and TypeScript for compiling the code, the TypeScript code. That's all. You should usually not have anything other than that. Anyway, so to get started with, I would actually make a new directory for the entities. We would need basically 3 entities here. We would need a board file, we would need game, and a player. Okay. Okay. So essentially a board should need, all of these would be classes. Okay. So class game, this would be class player, and this would be class board. Okay. So essentially we would have like the game would need a board and a player inside it. So and then we will run the game from main. So we will start a new game, something in the sort of game g equal to new game, and then game dot start. That's all we will have on our main file. Okay, so that's sort of how we will set up our project. Tests is to be able to run tests for our board, our game, a player, and then so on and so forth. Okay. So let's get started with the basic stuff that we will need. So for the player, we need, obviously, we have found out that we need a name and, sorry, and we need a character. Okay. What we can do is we can pass all of these two things inside a constructor. That when we construct a player, we pass a name and a character. We can also do a builder pattern kind of a thing as well. So what we can do is player dot builder, right? We can do a builder pattern so that we build a player, set name, set character, right, like that. Okay. For now, we can construct the player using a name and a character. Default character, as we have seen, is going to be X and O, that we will handle inside the game class. For example, we can do that. Okay. Board needs to have a sort of the grid itself. So we can actually have grid, which will be an array of an array of, we can actually do an array of a string here. Equal to, and we can actually write this itself. So we can do something like this. Okay. So 3 of these. So technically the board looks like this. Okay. So that's the grid. We will have to specify a way to print the board. So let's, and then inside the game, we will need to start the game, initialize the game. Okay. So that's sort of how our entities would look like. Let's get down into actually detailing out, obviously, the entities, right? So character, by default, we will create one. So game, what we will have is we will have P1 of type player. We'll have P2 also of type player. Okay. We will have to export these, by the way, and we have to export the board as well, and we'll have to export the game as well. Yeah. So player has to be imported. Yeah. And we will have the board. Okay. Got it. Now, if we have to create a builder kind of class, how do we handle that? So we can create a builder pattern for the player, and we can create a builder pattern for the game. The board did not have a builder pattern because we can straight up create a board and it has the grid at its initial situation already. Okay, so if we do here, basically, I think we don't need a export here. Actually, so we don't actually have a inner class kind of a pattern that exists in Java. So what we can do is we can basically have a player builder itself. So you can do like a player builder, okay, which should have a name and a character. It should have a constructor which has neither of these things. Okay, sorry, it should not have anything here. So we will do is create a setter for these two. Okay, and return this from both. Okay. Got it. Then we will have a build function. So we'll have a build function that returns a player type basically. Okay, and return new player where we pass this dot name and this dot character. Okay. In fact, yeah. We can make the constructor sort of private if you want to, like module private or something like that, which we do in Java. Here TypeScript does not really matter. We do it like this. So we have a player builder. Okay. So in game, when we sort of initialize the game, we will have to build the players basically, right? So that's one of the first things that we'll do. So game should also have a game builder essentially. Okay. So we will have a okay. As the game builder, we will set the player 1, set the player 2, and initialize the board. That's all that we need to do in the game builder. Okay. One of the main things about the player builder still is that we should not allow, if we have a builder pattern, then we should not allow somebody else to be able to build the player automatically. So one thing what we can do is we can do something like this. We can write static builder equal to, and maybe we can use the class player builder actually directly there. Okay. If we do this, then we can make the constructor as private, which would mean that in main.ts we can't write const p equal to new player. This is gonna be invalid because this is gonna be private. But what we can do is we can do pb equal to new player dot builder, and then we can do pb dot set name, and then dot set character, and then dot build. So this is gonna be possible. In fact, we can actually try this out. So set name, let's say my name, and then set character. Maybe my character is, let's say this, and build. So console.log pb dot, not pb, const p equal to. So now we can do p dot name and p dot character, right? So this, if I just sort of want to run, I think the start script should do it, is, yeah, Arnav and emoji that has sort of been built. Okay. If we want to, so that becomes my player builder pattern. Okay. Then sort of we can do something similar with our game as well, right? So what we can do is we can do static builder is class game builder. Okay. Now we will obviously have finally the build class. So we will have a build function that returns a game object, and we will do, so we can do a private construct. So we can do like basically a private constructor of all the three props, and this can create this. Okay. in terms of board, we can allow directly board creation because directly grid is there. So what we can do is here in sort of the build function, return new game. But to return a new game, we need a P1 player, a P2 player. Okay. So what we need here is P1 character. Okay. Or we can just do this thing. We can have P1 and P2 as players inside here as well. So we're going to create player 1, right? Inside create player 1, we have to read the value of the basically name of the player and character of the player, which we can default to X. Okay. So create player 1 P1 equal to new player dot builder dot set name. Sorry, set name would be this dot set character would be character and build. Okay, this dot p1 equal to this. So I will do something similar with creating the player 2. This dot p2 would be in similar fashion. Okay, and then we will create a new game where we will pass p1, this dot p1, then this dot p2 and new board. Okay, that's how we will build a game. But we will have to have some process here is that if p1, if this dot p1, sorry, if not this dot p1, okay, throw new, we have to create a new error here. Create player 1 before creating game, or you need to create player 1 first. And similarly, if p2 does not exist, then you need to create player 2 before building game. Okay, so now we have a good situation here is that when we want to create sort of the game itself. So if I do, let's say const game builder equal to new game dot builder, right? When I do that, then if I do gb dot build, okay, straight away, what will happen? I will get an exception. Get an exception that you need to create player 1 before building game. So I will have to do gb dot create player 1, give a name, right? And sorry, that's player 2. I have to return this from within here in each of these. Okay, so then dot create player 1. Let's say num1 is player 1, I don't know, is player 2, like this. Now if I run it sort of works. Okay, this will not work if I don't have any of these lines here. If I don't have player 2, it will also fail, again with the exception that we need. Okay, so we have a mechanism to build the game, build the player. Now we have to start adding all of the logic inside our board layer and the game layer. So the game needs to have the logic of moving to the next turn and asking for inputs and all of that. So essentially in our main thing, what we will really do is we will create a game using the game builder and start the game. Okay, so game.start, something like that, which will do every turn one by one. So the game will have the driver code, which is called the game driver, and the board would have sort of the logic for selecting each kind of variable. Okay, so let's go and try to build that. Okay, next what we'll do is let's start adding some of the methods on the board logic. So with the board logic, what we need to do is we will do a few things like we'll have a print board function that can print the board, and we will do like marking different spots in the board by a player. So let's start doing that. Okay, so of course we can have just print board. Okay, print board should be pretty simple. We just go ahead and print sort of console.log, and we print the board. What do we print here is we can do this dot grid 0 0, and we can have basically this. Okay, if we want to be extensible, we should do a row wise printing thing here. Actually, we should do print row 1, print row 2, print row 3, like that. We should so I'll just I mean, this is sort of hard coded. It's not extensible code actually here, printing it like this. Okay, so probably like actually iterating through the grids is kind of better. I will write, you can actually write some code here that this grid can be made extensible, like board size. Okay, so we can have actually something like const board size equal to maybe 3, something like this if you have like at the here. Now we can do like make it board size based. So that extensibility I'm not building actually right now. If we do that, that's sort of better. So we will cover that towards the end and see how it can turn extensible. But anyway, so 0, this will be, sorry, oh yeah. So this would be 1. This and this would be 2. This and this would be 2, and this and this would be 1. Okay. So that's sort of print board. Markboard, and inside markboard, if I do basically okay, so the box would be box A1 or B2, like that, and character would be the character that the player is marking. Okay, so to mark the board, we will have to obviously check a few things. So first of all, if box dot length not equal to 2, throw an error, invalid box identifier. Okay, then what happens is const row equal to, or something like box dot caret 0, right? And or we can do something like this, const row equal to a b c dot index of box caret 0, and const call equal to box dot caret 1. Okay, so then what we will do is, if grid this dot grid row call not if this equal to already underscore, in that case we can write throw error, or we can return a boolean here. Okay, and what we can do is in this case return false. We could not mark the board because that grid is already taken up. Okay, so this is the mark board function. Else what we do, this dot call equal to whatever character we are marking the board with. Okay, return true. Okay, So just to sort of try this part of the board out, we can try it on the main actually. So what we can do is const board equal to new board. Sorry, right. I call print board, board dot print board. Okay. Then I do board dot mark, let's say A1 with this character X. Okay. And then do board dot print board. Let's see how this looks like. Okay, this did not work. So print board worked, but marking A1 at X and still print board did not work. So let's see why that did not happen. We can do is, oh, sorry. So if it is not marked as underscore actually, so then we return as false. Okay. So yeah, this marking happens. One important thing is now we realize that in our game, we cannot allow people to have underscore as a character. So we can add that error here in player. So this dot character, if value, we can do throw new error. Okay. So we can't allow underscore as a valid player character. So mark board, this, okay. Cool. So that's how mark board looks like. Then if we want to sort of see get row as string, okay, which returns a string. So if you want to do that, okay. So what we want to do is if we pass row A, B, or C as a string, right? So row, we can do this same thing, const row equal to okay, and then we can return this dot grid of that particular row, and we can join it with an empty string. Okay, so this gives us certain things like board dot get row as string of row A. It will show this row itself. This is useful to find out who has won or not. Okay, so let's see, get row as string. We can do a get call as string as well. Okay, so we can take this one as a number actually. Okay, so we will basically do return, and we'll create an array of this dot grid row 0 of this particular call. Okay, we will through our inspection kind of things. So if call less than 0 or call greater than 2, we can have a throw new error here, 0 and 2, right? We can do something like this here as well. So if row name not equal to A, B, C, we can do A, or we can do something like this. If ABC dot index of this thing, basically if ABC dot index of row name -1, then row has to be A, B, or C, like this. Okay, So get row as a string, get call as a string, that returns our column as a string. We can print column number 1 here. Console.log board.get column as a string. Which column? I want column number 1 actually. That should print x underscore underscore. Sorry. Yeah, so this works. Okay. So we have got the row as a string, column as a string, and we can obviously. So we can have two diagonals, diagonal 1 and 2. So if diag number equal to 1, we can do this. Else if diag number equal to 2, we can do another thing, and else we can do error. Okay, so diagonal number 1 is gonna be technically 0 0 1 1 and 2 2, and diagonal number 2 would be 0 2 1 1 and 2 0. Okay, so if diagonal number 1 is this, then return. If diagonal number 2 is this, then return. Else throw new error, invalid diagonal. Okay, so get row as string, get column as string, get diagonal as string. We can print those values, which is useful to check if somebody has one in the board already or not. Okay, so the board, we don't really need anything else. We need to be able to print the board. We need to be able to mark the board. We need to be able to get rows, columns, and diagonals as strings. Okay. In the game code now, we will have to write the sort of driver code, which is basically play each turn, who has the current turn, check whether victory is there or not. Okay, so that's what we will do next. Okay, let's see now how our game code might look like. Okay, so we build a player, create player 1. I think we should do is add player 1 and add player 2. I think that should be better sort of names. Add player 1, add player 2. Anyway, so we do this. Okay, so this is to build a game. This is sort of done. This is the constructor. We need to also have this value called turn. Okay, so let's say we have turn equal to 0 initially. Okay, turn equal to 1 initially maybe, or we can do 0 as well. Okay, so let's say we have a function called play. So while turn less than 9. Okay, so we will do certain things, of course. When we reach like turn becomes 9 basically, right? So this is a draw condition. Okay, or we actually have, sorry, so if turn equal to 9, so with play, what we will do is we will take the box as string. Okay, so play box as string, whose turn it is. So player would be basically turn this dot turn modulo 2 equal to 0. In that case, p1, or in the other case, p2. Okay. Sorry, yeah. So this dot p1 or this dot p2. Okay. So this will be our player. Okay. Now, what we have to do is we check board dot mark board, the given box. Okay. With the character of player dot character. Okay. So we do is const success equal to this dot board dot mark board. Okay. Now, sorry. So if not success, okay, or rather I would say if success, then we do is we do turn plus plus, and turn should then not be a const, of course. So we do this dot turn plus plus, so turn increases, and if this dot turn becomes 9, then game should end. So basically here what we would have is game ended in a draw. Okay. Now if success, then we do turn plus plus. Else we don't need to do anything. We will just have to play again. Okay. So to play, what we will do. So if it has been successful, then we also have to check that whether, so we will also have a game state. So what we can do is type game state equal to started, won, draw. Okay. End winner, and we have end draw. Okay. So initially we will have game state. Okay, like this. So initially we have game state is started. Okay. We will change it to winner or draw. So if turn is 9, then state equal to end with draw. This dot and a straw. Okay. Now we have success. Then we need to check whether this was a winning move or not. Okay. So we can have a function private check winner. Okay. Now this winner would usually only be basically the current player who has turned, that is the player who can win. Obviously no other player, like the other player can't win in current turn. So if I am playing this turn, then after I have put something, then I can only be possibly the player. Okay. So check winner whether it's player is of type player and with the board. So what we have to do is player dot character. Okay. Const winning line equal to, basically winning line would be right. So this would be the winning line basically being the characters 3 times. Okay. So we will check basically A, B, C dot for each. We can do so rows dot for each. What we can do is board dot get row as string r if this is same as winning line, or we can do is for let row in A, B, C if this dot board dot get row as string uh, equal to winning line, then return true. Then for let call in 012, similar thing. If board dot get call as string in the call, then return true. Get call as string, are we taking call as number? We are taking call as number, right? So okay. Okay. Oh, we have to use off here. I'm sorry. So with the let call of 012, we do this, and then finally we do something similar for the diagonals as well. Okay. Else we return false. Okay. So do the check winner thing. So if check winner with this current player, then this dot state equal to winner console.log game over, and we will write the player who has won. So the player who has won would be game over, player has won. Okay. Then we can directly, I mean, we don't need to do the turn plus plus technically anymore. We can just return from here. Otherwise, we do turn plus plus. If turn becomes 9, then we can say we have, ended in a draw, game has ended. Okay. And we check for the success. Okay. We can create a function for the prompt as well. So we can do is the next turn prompt. So we can do is next turn prompt can be a string which says that this dot turn. I think we can do +1 actually. Turn number, or we can start from 0. That's, I don't know, it depends on the user use case. We want to show it from 0 or something like that. This dot turn +1, and we can do so. We can do the same thing here. Player dot name, and then we can do inside brackets maybe player dot character. Okay. So this prints the next turn prompt, and then we return as play, and then we keep continuing like this. So what we can do in the main section now is we can do something like this. I'll remove all of these things. What we need to do is we need to build the game, of course. So const game builder equal to new game dot builder. Okay. Player one name equal to, and this is where we will need to read data from the console a little bit actually. Okay, so what we will do is we'll use this import star as RL from. So we'll use this module called readline sync. What it does is we can do things like RL dot question, sorry, RL dot question, and we can pass a question here, enter player one name like this. Okay. So what we do, player 1 name, player 1 character, player 2 name, and player 2 character. So enter player 1 name, player 1, we will say by default it's going to be X. Okay. And player 2 name would be player 1 name. So in question, I think we can pass some options. Options, maybe I think we can have a default input. So we can do like this question. This default input is actually X for this, and here default input is actually for this. Okay. So then what we will do, game builder dot add player 1 with player 1 name and player 1 character. Okay, we'll do the same thing here. Okay, then we will do const game equal to game builder dot build. Now once game is built, we will run the game while game dot state equal to started. Till then, what we will do, const box equal to rl dot question, and inside question I will pass game dot next turn prompt, and then whatever we get in the box we do game dot play that box. Okay, most likely this should work. Let's see how does it look like. So enter player 1 name, let's say I do Joe. Player 1 character, let's say I put I don't know, I put some J here. Okay, player 2 name, and I put player 2 name as Paul, and player 2 character P. So turn 1 player 1, what do we enter here actually, right? So A1, we have a problem. So here, so apparently when we're doing get diagonal as string, we are passing diagonal 1 and 2. Okay, sorry. So we are supposed to check for diagonal 1 and 2 rather than 0 and 1. Or rather I can do this and check for diagonal 0 and diagonal 1. Okay. So what we have to do here is after every turn, we have to print the board as well. So I forgot doing that. So here inside game, if board is success, this dot board dot print board. Okay. Or inside main, I think I will do a little bit of difference. So I will do game dot next turn prompt like this. Okay. So now we have enter player 1 name Joe. Let's say we go with J. Paul, we go with P. So turn 1 player Joe, enter box. So I go with A2. So J here. Paul will go for B1. Okay. So like this. And then we pass A1 maybe like this. And then we will have, oh, actually, we need to index it up actually. So according to our problem statement, which we had A1, A2, A3. So our row numbers should move one more. So here when we add mark board box, so box dot length, so row is this, call is going to be this plus 1 actually, minus 1 technically. Okay, so number is going to be box dot character at 1 minus 1, so we will mark it accordingly. Let's play it again. So player 1, let's say we go with Joe, we give default X, we go with Paul, maybe default Y. So enter box A1. Paul would go for, let's say, B1, then A2, B2, let's say, then A3 if we go. So game over, Joe has won. I think we should print the board state for all the cases, so we can do that. Maybe what we can do is this dot print board. We can do it for all the cases, whether or not success. Okay. So we print the board, then we ask for the turn like that for everybody we will do. Small typo here. This is by default supposed to be O. So that's pretty much it. Our basic game sort of is working at this stage. We don't need to import board. We don't need to import player. Yep. So let's start again. So player one name, let's say Arnav. Player one character, we can go with an emoji maybe. Then player two name, Naman, maybe another emoji. So enter box A1, enter box A3, let's say B3, B1, right? C2, C3, A2, A. If I do A1 again, if I keep doing A1, it'll have to, same player has to keep on with that turn. We need to show the error as well that, box already taken. We should do something about that. But anyway, we can go with B2 and then finally with C1. So game finish in a draw. So basic game logic sort of is working. We haven't added the tests yet. We should add the tests and all of these error conditions to be shown. We should do that as well. Okay. Okay, so let's see how to add a little bit of testing code. So to test, let's say we add one TypeScript file which will test for test board.spec.ts add. So we write tests like this. Test name of the test board initialization works. Okay. Don't really need the assert done callback, I think. So this is basically to check some errors inside the done callback anyway. So what we do is we will do stuff like this. So to check for the board initialization, const b equal to new board. Okay. We have expect b dot get call as string 0 dot to equal. So we do for 0 1 2. Get row as string also. A B C same thing, and get the diagonal also. Get diagonal as string, diagonal 0 and diagonal 1 to be the same. Run the test. We need to call assert at the end. I think assert should be called with anything, I think. Yeah. As long as it is not with an error. Awesome. So board initialization works. So test board marking works. So for that, what we will do, const b equal to new board. something like this only. Then b dot mark board a1 as, let's say, k. So expect b dot get row as string a dot to equal k underscore underscore, and b should be fine. Expect b dot get call as string also 0 column to also be equal to this thing only, and finally set. Okay, so board marking works. This works. Okay, technically we can run all tests also. So board initialization board marking works. Okay, we should be able to run all tests with coverage as well. So when we run all tests with coverage, we will see that inside my entities and board file, there are still some lines not covered, which is we are not checking whether the marking identifier is wrong. If that's the case, we are checking that or not. If we are trying to mark a board which is already marked, we are checking for that or not. Okay, so we will have to check those as well. Mark board should be false. For that case, we should check that. Get row as string wrong value we have not tested. Okay, so when we test for coverage, we will see that there are certain lines we have not tested, which means we only tested the successful cases, not the unsuccessful cases. So we should test for the unsuccessful cases too. So to do that, what we need to do is test. Okay, how to do this? So repeat marking returns false. So b dot mark board a1 character k const attempt 1 const attempt 2 equal to b dot mark board again a1 with any value, let's say 0. Okay, so we have to see expect attempt 1 dot to be truthy and expect attempt 2 to actually just to be true and false. Okay, so let's try this. Works fine. Okay, so we have to check that if we mark the board again with the same parameter, we get false. If we run this with coverage, we will see our coverage. Of course, if we run all tests, some coverage increases. Mark board with the false condition, this gets covered. Still don't check for whether the box name is invalid. How do we test for that? So that also has to be tested for. Okay, so we have to do const b equal to new board. Now if we do expect, actually here we will do b dot mark board on say a3. A3 is there, a4 mark with any letter, let's say G or 1. Okay, dot to throw, and we have to throw which error? Actually it should throw invalid box identifier. So level 1, expect this dot to throw, since it didn't throw. Why? Because we are not checking for number 4 here. Okay, so we have to check that if row less than 0 or row greater than 2. Or call less than 0 or call greater than 2. We have to throw the same error here. Okay. If we are doing twice error like this, we can do is we can do inner class here. Extends error. We can override the message equal to invalid box identifier error. And then we can do this invalid box name error. Okay. So then we can check with this, tests. Okay, apparently that didn't work. Expect this invalid box identifier at board.markboard. Okay. Okay, we have to actually create a function here instead. I think this should test correctly. Yeah. So we expect a callback function inside which we can do certain functions and expect this to throw. Okay. We can try out with a few more as well. So if I try out with A0, it should also throw. If I do A, B, C, if I do D1, this should also throw. If I do with a single letter A, that should also throw. If I do it with 3 letters, A01, they should also throw. So that's sort of correct where it checks all the possible cases. Does this test actually cover everything? Let's try all tests with coverage. We see that board.ts is still 84% covered. There are still places which are not covered. For example, the get functions are still not covered. Get row as string, get call as string, get diag as string. All of these are not covered. Okay. So we should write tests for these as well. Okay. So in fact, in the board, what happens is if I do get row as string and I pass something that's not ABC, then we should get this error. Okay. If call is wrong, I should get this error. And if diag is wrong, then I should get this error. Okay. So we need to handle that as well. So let's go for the tests. Okay, so here what we will do is expect, so we'll simply write const b equal to new board, and then we will do expect to throw. What do we need to throw? So for the row 1, b dot get row as string, and if I pass d, similarly now, if I do get call as string and I pass 5, then my error has to be call has to be between 0 and 2. And then finally, the diag one, if my diagonal is 4, then I need to get invalid diagonal. Okay, let's see, this test should also pass. Oh, I have forgotten calling assert at the end, signify the tests I went. Now the thing is that if I run all tests now with coverage, my board would almost be covered, 96%. The only thing is we have not tested the print board function. So while this is not a functional thing, it's just a printing, we can add a test for that if we need to, if print board was returning something. Console.log functions can't really be tested. So that's test for the board. So we should then similarly have tests for our game as well, for our player as well. Okay. Player, we should just need a builder test that player can be built. Game, we need to do the entire test of the logic. Can check winner, check the prompt, check play, all of that stuff we need to check for, and we need to write tests for the same. Okay. So I'm updating all of these things. I would just add a commit for this. Tests for the board logic is done. So actually on the same repository where we had the problem statement, there we have the solutions in TypeScript as well. Okay. And here there are the test files written that I've just added the tests. The code for the board is also there. The code for the board, the game, and the players and everything. So the entire solution is also there, the same repository. So you can go there and check the code. I would actually update the code with the tests for the game and the player as well. Okay. So the next question that comes, of course, is like, what are the things which are actually not extensible, which not designed well yet in this game, and we can make them extensible. We can make them better designed than what they currently are. So for that, I'll just remove the coverage right of everything. Yeah. So for example, the board hard coded to 3. We read that one of the things that it wanted was the problem said that you need to make it extensible to change the size of the grid, allow different types of pieces. Different types of pieces actually we have already allowed. More than 2 is something that we have sort of not allowed yet. Okay. So how do we do those kind of things as well? So to do those kind of things, first of all, let's say, for example, the board, this grid, this format, not good. We change this to what we will do. We will have a const here, const board default size equal to 3. Okay. What we will do here is we will create a constructor for the board. And in the constructor, we instead of taking the grid, actually, we will take here size number equal to board default size. So if no size is given, we will take the default size. What we will do? We will do this dot grid equal to an empty array. Then for let I equal to 0, I less than size, I plus plus. What do I do? Grid, this dot grid, and inside that we push new array of size, whatever the size is, grid size, and we fill it with underscore. Okay, that's it. So that way, and then we have to change the print board part as well. So the print board part, actually, I will change it a little bit. So instead of doing a console log, we will actually return a string actually rather than print board. So there are a couple of places. There's only one place where print board is called. So we'll call it get board for display. Okay. And what we will do here is we'll do like this. Return this dot grid. So actually, we will do like this. Const display rows equal to an array. Okay. We will do for row, for let row of grid display rows dot push this dot grid dot join with tab actually. This dot, sorry, this row dot join with a tab. Awesome. And then we will do return display rows dot join with a new line. Okay. So then wherever we had this in the game function print board, we will do instead of this in the next turn prompt. What do we do? This dot board dot get board for display. Get board for display. And then we have this turn message. Okay. Or we do this and plus /n plus and we have this string. Okay. So we do this plus /n plus this. Okay. Get board for display like this. So let's see how our board looks like now. Player one name, Kate, let's say Roman, something like this. Okay, so board looks like this. Enter box A2, A3. Awesome, works, right? So that's how our board looks like now. We can add, let's say maybe initially some this as well. So that way. So now we have some space after each as well. Okay. One part not covered is, so my board can be constructed with any size now, though we don't know what's going to be the row numbers and all, etc. Okay. So what we can do is, okay. So what we will do is we can maybe use all the letters. We can put the upper limit at, let's say, 26 or something like that. So up to 10, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now what we will do is we will do this. Rows dot index of. So if it is greater than 0 or greater than so we need to actually store the size of the board as well. So our board of size would be size. So this dot size equal to size. Okay. So now we will write if row is greater than this dot size, call 0 or call is greater than this dot size. Okay. Similarly, get row as string. So this would be rows dot index of this row has to be 1 off, and we can do here rows dot substring. We can do 0 comma this dot size. Okay. And again here we can do rows dot index of row name, get call as string. So get call as string would be this dot size from here to size. We can't print it this way anymore. We will have to handle this using a for loop now. So what we will have to do is we'll have to do call vals dot push this dot grid I and call. Okay, and then we will return call vals dot join. Okay, have to do the same thing with diagonals. So if diagonal is 0, we will have to return again for loop. We will have to do basically. So right. So if this, then for let I equal to 0, I less than this dot size I plus plus, and we have to do diagvals dot push this dot grid I comma I, right. We'll have to do I and this dot size minus I for the other one. So for this one we will have to do I and this dot size minus 1 minus I. Okay, so if it is 3, then it will be 3 minus 1 2 1 0, like that, right? So then we will have to do return diagvals dot join. Here also return diagvals dot join. Okay, so we have made these changes. We haven't made any changes in the test board. Let's see if all the tests work or not. So we have to update some tests. So the test that need to be updated is, so here what happens is that A4 invalid box identifier should have not coming, which means we will have to go to markboard and check why is it not coming. So if row is greater than or equal to, we will have to do, and call greater than or equal to, we will have to do to run again and see. So get row as string, here also we will have to check this. So if row equal to, we'll have to do like this. Okay, so if row num, so if row num is -1 or row num greater than equal to this dot size, this dot size is supposed to be a number, right? Let me see. Sorry, row num. Yeah. Got it. Now let's see. So here there is a little bit of an issue. So because the error is not constant anymore, right? So we can't expect exactly same issue here. So what's happening here is when we are checking, this row has to be one of, this is the expected error here. So inside tooth row, of course, we will have to we can't have exactly the same string actually. So what we can do is rather than this, we can pass here something to do row number is invalid. Maybe we can, that's the same error that we can do there. Okay, this way at least we will get the errors to match. We can mark with regular expression the initial part of the error as well, but nevertheless. Now you see, we have done this exercise which makes our board actually, on the error side. So there are a couple of things. Having these tests help us in one very important thing. As you can see, I did not change anything in the tests. But as soon as I updated my board, some of my tests started failing, which means that there were certain parts of my board's checks which were not correctly done after the extension. So that's why having tests help. And in most cases, like for example, in the test, the only thing I needed to actually change in test was this error name actually, because we are having a little bit of difficulty matching the error name. We can actually make that work correctly using error types rather than error names like this. But nevertheless, as you can see, these errors I did not change. Like these are the lines which are changed actually. These gray identifiers here, as you can see. So as you can see, there's nothing inside board that has changed. The board test that has changed. Just by updating board, we were able to run the tests and see that whether the tests are passing or not, because the test should continue to pass, because although I made my board class more extensible, the previous functionality for the hard-coded board class of 3 rows and calls should continue to work nevertheless. I mean, I have expanded the functionality, but it does not mean old functionality should stop working. So that's one of the, test, that's a validation that the test we had written was correctly written, because these tests continue to work even after I have refactored my board class logic. So my board class is now pretty extendable. I can create a board of any size that I want to. We can, in the main player, we can get any type of size of the board that we want to, but our logic in the game will not match if the size of the board is not correct actually. So we have these hard-coded logics here which will not match, and the reason they will not match is also because game, we don't have tests yet for the game. So because our board is now extendable, but the game is hard-coded to 3 size boards. So we need to fix these. Okay. So let's see how we can fix that as well. Or maybe you can try and fix that, send a pull request to this repository, which where our code is. But for now, the board has become extendable. The game we still have to fix. Okay.